In addition to channel power and adjacent channel power measurements discussed in the last video, occupied bandwidth measurements are essential for network verification testing in the field. Occupied bandwidth measurements on a spectrum analyzer look similar to total channel power measurements, but instead, they determine the bandwidth where the majority of the signal lies. Since power leakage has significant effects on communication systems, several regions, like Japan and the US, have occupied bandwidth regulatory requirements. Occupied bandwidth measurements help you determine if your transmitter is operating properly. Typically, any distortion produces power outside of the specified bandwidth. Occupied bandwidth measurements allow you to see this distortion, like shoulders on the side of the spectrum or rounding and sloping on top of the spectrum. These issues indicate intermodulation or filter shape problems. A spectrum analyzer with occupied bandwidth measurement capabilities computes the channel power, then places the marker lines at the frequencies that bracket 99% of that power. All you have to do is input the carrier frequency, and the occupied bandwidth measurement automatically determines the 99% bandwidth. The default percentage is 99%, but you can customize it. Like adjacent power and occupied bandwidth, spectrum emission mask, or SEM, measurements are important to verify power leakage too. Since ACP and occupied bandwidth measurements use integrated power, they don't detect the emissions at each frequency band. SEM looks at power levels at specific frequencies and offsets rather than integrating across the entire band. SEM measurements on a handheld spectrum analyzer help you visualize channel limits and determine compliance for your spread spectrum signals. It measures the excess in-band and out-of-band emissions that interfere with adjacent channels and other systems. The SEM function measures the levels of spurious signals in several pairs of offset frequencies and relates them to the carrier power. It performs a segment sweep, segmenting a different frequency on the lower level and upper level from a reference center frequency. Each segment may have a different frequency span, resolution bandwidth, and different integrated channel bandwidth settings. If you experience failing, you need to identify which frequency components are failing. Identifying these components may require other measurement functions available on the analyzer, but detecting the failing component using SEM is the first step to getting your network on track to high performance and compliance standards.